So for our first example, we're going to look at just what happens physically to the points if you're talking about your inverse. And do remember, if you have the ordered pair x comma y for the function f, then for f inverse you have the ordered pair y comma x. So based on that, and looking at our table that we're given, here if x is 2, then f inverse of 2 is 3. If x is negative 1, then f inverse is 1. And finally, if x is 4, f inverse is negative 1. And completing the chart for g and g inverse, it's the same process. So if x is negative 1, then g inverse is 3. And then we would have 0, 1, and then 3, negative 1. Now with working through some of the problems involving your inverse, so for the first one, we want f of g inverse of 0. So we always start with the innermost part, and we have g inverse of 0. And if we read our chart, g inverse of 0 is going to be 1. And then we move to the outer part and replace g inverse of 0 with 1. So now I need, well, what is f at 1? And remember, f at 1 is going to be negative 1. Moving on to part D, very similar, same process. So we need to see that f at negative 1, that is 4. And then we need f inverse of 4, and that's going to be negative 1. So for our next problem, we need to find g inverse of negative 1. And if we look up at the chart, g inverse of negative 1 is going to be 3. Now we're going to replace that value. So now we're going to look for f inverse of 3. And that's going to be a problem because f inverse of 3 is not going to be defined. We don't have a value. So this does not exist. So this entire problem up here would not exist. Now for part F, we're going to first find f inverse of 4, which looks like it's going to be negative 1, and then g inverse of negative 1, and that's going to give us 3. And for our next problem, we're given f of x. We're told that f prime at 2 is 4, but we want to find f inverse, or the derivative of f inverse of 5. So let's set up our formula. And so all of this, and I'll go ahead and rewrite it. We have f inverse of 5, and we need the derivative of that. And so for us to remember the formula, it's 1 over, and we're going to say f prime of f inverse of 5. That's what we're looking for. So we need to first find f inverse of 5. That's our first step. Now f inverse, we're not given the inverse function. We have two options. We can find the inverse function, or since I know this inverse function changes our x and y, then instead of substituting in 5 for x, I can substitute it in for the function. So in other words, this means the same thing. F inverse of 5 is 5 equals 4x minus 3. And to solve for x this way, we would add 3 over, and so x would be 2. So that tells me then that f inverse of 5 is actually 2. So continuing on here, then I'm going to look for f prime at 2, which is going to be pretty easy because we were told f prime at 2 is 4. So my answer is going to be 1/4. This next slide gives you some step-by-steps that you can follow when finding the derivative of the inverse. Now notice their notation. We've been using f of x and g of x, but nothing says we have to. We can also use this notation they're given, and yes, you might see it written this way. And it's for a point AB on f of x. So notice your process here. To find the derivative of the inverse function, you first find the derivative of the actual function. If you're only given b, in other words, that's just your y value, then you can say b equals the function to find a. Find the derivative of a. And so notice what the rest of this is. It's just going to be 1 over f prime at a. So if you go these steps, that's fine, or we can continue with what we're already doing. Now the important thing from this that I want you to take away is this portion right here. So if you're only given the x value, you can set your original function equal to that in order to find that inverse value that you need. Okay, so let's go ahead and notice that we're given that g of x is the inverse of f of x, and we want to find g prime at 1. So I would go ahead and let's write in what that would look like. Substitute it into our formula. G prime at -1 is going to be 1 over f prime of g at 1. And so now we need to be able to read our chart. And if I'm looking for g at 1, then that means I need to go look for, or g at -1, sorry, g at -1, then I need to go through here seeing where not necessarily a y value is -1, or an x value is -1, but a y value. So what you could do through here, and it's a good idea, let's go ahead and talk about the function g of x, some ordered pairs on that. So if we talk about the ordered pairs here, then notice that with g of x, instead of having 2, 5, you're going to have the ordered pair 5, 2. And then here for the next one, you're going to have the ordered pairs -1, 3. And then the final one you're going to have is 4, -1. Now, based on the slide that we just talked about earlier, we could also talk about g prime at x right here. We could look at that because that's 1 over f prime of x. So if we do 1 over 0 here, that's not going to exist. This other one would be 1 over -1/4, or 1 over -4. And then finally, we're going to have 1 over 6. So that might help us figure out, well, okay, well, g prime at -1 is really going to be 1 over, and we need to find f prime at, well, g at -1 is 3. So I need 1 over f prime at 3. And so f prime at 3 is 4, so I need 1 over -4, or -1/4, which really kind of lines up with what we saw up here in our chart. So either way you want to do this is fine. For this next part, we're going to talk about these derivative rules for inverse trig functions. We're really going to look at where these come from, and then from this point forward, you can just memorize the formula if you want to. So this notation here looks kind of intimidating, but what we can do is say, well, originally, let's move this inverse sign back over here, and this was originally saying sine of y equals x, and then once again, let's do the derivative of both sides. So I want to do the derivative over here, d dx, and the derivative over here. So what that's going to be then is the derivative of sine of y is cosine of y, but we've got to also multiply by the derivative of y, which is going to be dy dx, or y prime, whichever you want to state. And then over here is going to be equal to 1. And again, we're solving for that derivative, that dy dx. Well, that's going to be 1 over cosine of y. And then that 1 over cosine of y, if you'll look at your triangle, cosine, remember, is going to be your adjacent over your hypotenuse. So adjacent is going to be here, hypotenuse is going to be here. So we see very quickly that we're going to have 1 over, I'm going to fill that in, it's going to be 1 over the square root of 1 minus x squared. So you can go through these steps every time, or you can memorize that the derivative of the inverse sine is always going to be this down here. Okay, by the similar process, we can set this up and show where that formula is coming from. So again, we can move this back over. So we can say, well, this was originally saying cosine of y equals x, and then we can do the derivative of both sides. So the derivative of cosine is negative sine of y times dy dx equals 1. And then we can divide over. So we would have our dy dx equals 1 over negative sine of y. And then we can pull that the sine of y over on the other side is going to be, here we've got that negative. So negative 1 over, and it looks like we're going to have the square root of 1 minus x squared. And again, finally, the inverse tangent. Very similar process again. We're going to say, well, that was really tangent of y equals x, and then do the derivative of both sides. So the derivative of tangent is secant squared y, and of course your dy dx, and all of that's equal to 1. And so dy dx is equal to 1 over secant squared of y, which is the same thing as saying secant y all squared, which is going to be hypotenuse over your adjacent. So that square root, once we square it, does disappear. So I'm left with 1 over 1 plus x squared. And again, you're welcome to set up the triangle and work through it, or memorize the formula. Here would be all of the formulas. Now notice instead of x, we did change this to u's, and that's because, please remember that anytime we have any kind of angle other than just plain old x, we do have to do the derivative of that, and that's what these u primes are representing up at the top. Now this through here you may or may not see. I will not, I need to clarify. The only one I'll test you on would be the arc tan, and then these 3 that we just talked about. Those you need to be responsible for. All right, now let's look at how to implement this formula. And again, we can go through and look at our formula. We do need the derivative of arc sine, or inverse sine. And our formula for the derivative of that, just our general formula, is going to be u prime over the square root of 1 minus u squared. Now it does help for us to define what u is, and that's going to be our angle itself. That's going to be our value for u. So then our derivative for this would be the derivative of 5x, which is 5, over the square root of 1 minus 25x squared. And again, that's just substituting straight into our formula. Now let's try that with part B. And again, the formula for the derivative of inverse tangent is going to be u prime over 1 plus u squared. Now we do have to define, well, our u value is all of this inside here. That's going to be u. So then u prime, and we do have to think about this as 2x plus 1 all raised to the 1/2 power. So the derivative of that is going to be 1/2 times 2x plus 1 to the negative 1/2, and then times the derivative of the inside. And so that's going to allow us to cancel out some stuff. And then, of course, u squared would just be our 2x plus 1. So the derivative of all this, so dy dx is going to be, again, u prime, which we just saw, to be 2x plus 1 to the negative 1/2, all over 1 plus u squared, which is going to be, if I just square that, 2x plus 1. And you're welcome to leave it just like that and try to match up your answer choices when it's multiple choice. Okay, we're going to move along, and same process for C. Again, we're talking about the derivative of arc cosine, or the inverse cosine. And the derivative for this is going to be negative u prime over the square root of 1 minus u squared. And so now we're going to go ahead and identify, here's our value for u. So our dy dx is going to be the negative, or the opposite, of u prime, which is going to be 2x. And all of that is over the square root of 1 minus u squared. Well, let's see, u squared is going to be x to the 4th. Okay, so continuing on with using our formulas, again, the derivative of the inverse sine, that's going to be u prime over the square root of 1 minus u squared. And all of this is going to be your value for u. So dy dx is going to be u prime, so that's going to be 2x over the square root of 1 minus, and then u squared, so that's going to be x squared minus 1 all squared. And I would leave that just like it is. Okay, now continuing on, we do need to talk about the derivative of the inverse tangent. And again, that formula for the inverse tangent is going to be u prime over 1 plus u squared. And now this time, notice our u value is a trig function, cosine, so that'll be all right. So we're going to do dy dx is equal to u prime. Well, u prime, or the derivative of cosine, is going to be negative sine of x over 1 plus u squared, so that's going to be 1 plus cosine squared x. And that should be it. I don't believe I would try to do any more simplifying to that. Okay, and again, same thing with f. Again, we're talking about the derivative of inverse sine, and the derivative of inverse sine is going to be u prime over the square root of 1 minus u squared. And again, right here is your u value. So dy dx is going to be, well, u prime, or the derivative of e to the x, is just e to the x over the square root of 1 minus e to the x all squared. And that you might see rewritten to be e to the x over the square root. And remember, exponent raised to exponent, you multiply those, so 1 minus e to the 2x. Don't put x squared there. That's going to be multiplying 2 and x. That's why it's 2x. And now we're a classic equation of a tangent line to the graph of this at this given point. And one of the very first things I would do here, y equals arc tan that x over 2. Some of us are having trouble with that. Let's rewrite that to be 1/2 x, and that does tend to help. Now we do need our derivative because I need the slope to write the equation of that line. So dy dx And again, right here, so we need our u prime, which is going to be 1/2 over 1 plus u squared, which is going to be 1/4 x squared. So that's going to be our equation for our tangent line. And so let's see, what we'll need to do now is do some substitution. Notice our x value is 2, so we need to evaluate this derivative at the value of x equals 2. And so we're going to have 1/2 over 1 plus 1/4 times 2 squared. And so it looks like we're going to end up with 1/2 over 2, which is going to give us 1/4 for our slope. And so now let's write the equation of our line. So we have y minus pi over 4 equals our slope 1/4 times x minus 2. And you can leave it like that, or if this was in a multiple choice situation, you probably would see this plus pi over 4. So for this next problem, we're back to filling in a chart. And so let's take a moment and look at what these chart values, the ordered pairs, would be. So here, our G inverse would be 5, -3. That would be our ordered pair here. And our next ordered pair would be -1, 0. The next one, -3, 2. And finally, the last one is going to be 2, 4. So we have our ordered pairs. Let's go ahead and jump over to doing these problems. And again, just in general, if we wanted to find the derivative of the inverse at 4, what we need to remember here is that our formula is going to tell us that if we need f inverse of 4, that's really going to be 1 over, and then we're going to have f prime of f inverse at 4. And so let's go ahead and see, the first thing we need to do is find, well, what is f inverse at 4? And if we go back up and look, f inverse at 4 is going to be 2. So now we're going to say, well, now I need 1 over f prime at 2. And f prime at 2 is going to be 1. So I have 1 over 1, which is just 1. Right, number 8, very similar, same process. We need to find the derivative of the inverse. So if we wanted to find the derivative of that inverse, then we're going to have 1 over g prime of g inverse of -3. And now we need to go through looking at our chart. And so we see that g inverse of -3 is going to be, let's see, it looks like it's going to be 2. And then we need g prime at 2. And g prime at 2 is 2. So I have an answer of 1/2. Right, moving on down. Now the next is the equation of the tangent line. So we need a couple of values here. And we're talking about when x is 2. And we need the line to be tangent to the graph of g inverse when x is 2. So a couple of things we need. First, we need to know, well, what is the value of g inverse at 2? And reading our chart, that's going to give us 4. And now we need, because again, remember our formula, we're going to need that derivative value. In other words, I need the derivative's value, g inverse of 2. I need that derivative value. So that's going to be 1 over g prime, g inverse of 2. And so now we're back to reading our chart. So that's going to be 1 over g prime at 4. And so that's going to give me 1 over -3, or -1/3. So we have everything now that we need to write this tangent line. So we're going to have y minus 4, and that's coming from this. There's our ordered pair, equals our slope, which is what we just found, times x minus 2. And so we can either write it that way or we can add that 4 over. Either should be fine.